Recording. Raise your hand. And let us pray. In nomine Patris, et Filii, et Spiritus Sancti. Amen. Sancta Miguel Arcangelo, defende nos in preo, contra nequitiam et insidias diaboli, est presidium. Impere illi Deus, supliceste precamur, tuque princeps militiae celestis, Satanam, aliosque spiritus malignus, qui ad perditionem animarum pervegantur in mundo, divina virtute in infernum deturum. Amen. In nomine Patris, et Filii, et Spiritus Sancti. Lemon tag, right in the middle of prayer, that's awesome. Anyway, take out your notes, please. I want to finish off what we were talking about. I have two new things to show you. They're brief, and they have a lot to do with what we talked about yesterday. Yes, ma'am. Oh heavens to Murgatroyd. Yeah, the 20 minutes in ahead of time. Tell you what, would you forgive me if I did 15 minutes of notes and then just didn't check today's homework till tomorrow? And I'll give you plenty of time to work. That worked out. Because I don't trust my memory to remember to do this today, tomorrow. That didn't make sense. So, this will work. God willing.
Mr. Cog, was it 1 through 5?
It was 1 through 15. That was a typo. Okay, that's for tomorrow. I'll check it out. All right, take a look up here, please. Could somebody tell me, I'll tell you right now, there is a long way to do this and a short way to do this. Name the long way to do it. You don't have to do it, but tell me the name of it. Long division, hence the name. What's the short way called? Go. Synthetic division. Was anybody not here yesterday?
Oh, yeah, I wasn't here yesterday.
Okay.
Me either.
I need to give you a crash course in synthetic division. It's at least sometimes a substitute for long division. And it is a quite fast substitute for long division. There are times when it doesn't work, and I'll tell you when. But can somebody talk me through how to do this? Now, tell you what, I will turbo this as best I can. X plus 2 into x to the 4th plus 5x cubed plus 2x squared plus 6x plus 7. All right, here we go again. I did this 2 days in a row. Watch this. Okay, 2 digits go into 1 digit? Nope. So there's a 0 here. So can 2 digits go into 2? Yes. How many times? You look at the first and the first. So how many times does x go into x to the 4th? I don't know. Let's find out. X to the 4th over x is equal to x cubed. Put that up here. You notice they line up very nicely. Thank you very much. This multiplies to this, but 1-digit math. X cubed times 2 is 2x cubed. X cubed times x is x to the 4th. And I was about to subtract, but subtraction is a disaster. I'm going to add the opposite. Cancel. 5x cubed plus negative 2x cubed is 3x cubed. We're done with the first cycle. Yay. Bring down the plus 2x squared, and let's try it again. First into the first. How many times does x go into 3x cubed? I don't know. Let's find out. 3x cubed over x turns out to be 3x squared. That's up here. Multiply that. 3x squared times 2 is 6x squared. Plus 3x squared times x is 3x cubed. By the way, a quick side note. If you do these steps correctly, the first term should always cancel. It should always cancel perfectly. Add the opposite, cancel. This is going to be negative 4x squared. Looks good so far. Carry down the plus 6x. Let's try it again. First into the first. How many times is x going to negative 4x squared? I don't know. Let's find out. Negative 4x squared divided by x is negative 4x. Let me catch my breath. Plus negative 4x. Multiply that. Negative 4x times 2 is negative 8x. Plus negative 4x times x is negative 4x squared. And I'm going to add the opposite. Keep note. Opposite of negative is positive. Cancel. This is 14x. I'm going to bring down plus 7. And then one last time. How many times is x going to 14x? I don't know. Let's find out. 14x over x is equal to 14. That's plus 14 here. You'll notice all the terms line up perfectly. The cubes are above the cubed, the square is above the square, and so on and so on and so forth. Do remember from last chapter, if there's a missing term, if they skipped from x to the 4th to like 2x squared, what would you have to do in between? Everybody's so used to having me rattle off fucking auctioneer that I'm going to slow down for a second. Somebody tell me. If this were just x to the 4th plus 2x squared, what would I have to put in between? What would I have to force in there? Because I can't have any missing spots. Yeah, and if it's a blank, how many x cubed? One would actually exist. Zero. 0x cubed. If this were just x to the 4th plus 2x squared, you can't have any missing terms. Otherwise, long division then won't line up properly and I'll get the wrong answer. So you have to fill in any missing terms. So let's keep going. This is 14 multiplied by this is 28 plus 14x. Add the opposites, is negative 21. So you should have plus negative 21 over x plus 2. That's long division. And there's the quotient. So who remembers this from yesterday? The thing that you're dividing by, what's it called? Hand raised over here. The thing you're dividing by, what's it called? Way back from 5th grade or whatever. Go. That's the other one. That's the other one. There are 3 of them. Go. The divisor. Divisor. The thing you're dividing into is the dividend. And then the answer is the quotient. You need to know that because in order to do synthetic division, you have to know which parts are which. How does synthetic division work? How do you start? What do you draw first? It's dramatically shorter than this. But how do you start it? You draw a what? Yeah. A box. It looks like a half box. This is a box. This box is going to hold a number. The number we put in it is going to be called the box number. That's the name. Can you tell me how to get it? How do you get the box number? Look in your notes from yesterday if you need to. Go.
Set the divisor equal to 0.
Set the divisor equal to 0. And solve. You can probably do that in your head. In other words, look at the x plus 2. If you set that equal to 0, actually Spencer, take this one. If x plus 2 equals 0, what's x? If you just set this piece equal to 0, what would you get as an x? Negative 2. That's the box number. Does that make sense? If this were an x minus 2, I'd be putting positive 2 in there. If this were an x minus 7, I'd be putting 7 in there, and so on. Now, what do I draw next? Blaze. What do I put here? Just the numbers. We had a question yesterday. What's easier? Long division with plain old numbers, like we did in 5th grade or whatever, or this stuff? And the question is long division with just numbers. It's way easier. Somebody in the math world hundreds of years ago agreed, and they said, I wonder if I can just strip out all the x's and just do the numbers. It looks like this. 1, 3, negative 4. What? No. I'm looking at the wrong row. 1, 5, 2, In other words, here's the original problem. I just took the coefficients, nothing but. I could have looked over here, I suppose. You see where I got them? So the box number comes from the divisor, the thing out front. And then this string of numbers comes from the dividend, but just the numbers. Strip out all the x's. Skip a line and draw a line. So leave one line blank underneath it, and then we're going to have another line space underneath that. What do we do now? The funny thing is, this is called synthetic division, but you never actually divide. You do two math operations over and over and over. Thank you. Over there. Add and multiply. Do it for me. Here's how you do it. The very, very first one, add downward. What's 1 plus nothing? Yeah, no stress there. Then take that and multiply it to the box number. What do you get? -2. Put that in the next slot. So people who were not here yesterday, does that make sense? So you see where these numbers came from? First of all?
Yeah.
The 1, 5, 2, 6, 7. It just came from here.
Yeah.
All right. Now, the two techniques we're going to do: add, multiply, add, multiply, add, multiply. Keep going until you run out. When you multiply by the box number, and then put the answer in the next slot. I can keep going. Add for me. 3. Multiply. Yes. Add. Multiply. Add. 14. Multiply. Add. We're done with synthetic division. What the heck does that mean? Well, look over here. You see those numbers we came up with, the 1, 3, -4, 14, and -21? Look over here. 1, 3, -4, 14, -21, 15. It just did the division for you. You have to translate it. This used to be 1x to the 4th. When you're dividing by an x, you're dividing by an x plus 2. That means you're going to rip out 1x, a single x from each one. So what's this going to be? Actually, go ahead. X to the what? Exactly. And then put pluses in between everything. Now this used to be x cubed. What is it now?
X squared.
Yeah, you just follow the pattern now. What's this going to be?
X.
X. What's that?
X.
Oh, you already had x. Just number, correct. Plus, and this last thing, we ran out of everything else. What must that be? That's called the what?
Just like, oh, the remainder?
The remainder. It's plus -21 over whatever the original thing was. That's synthetic division. It's dramatically faster than long division. Once you get practiced at it, it takes about 10% of the time. It takes about 10 times longer to do long division, on average. At least when I do it. I time myself. Why? Because I have no life. So, questions? Actually, I do. But, yeah. Questions on that topic? I want to try one that can possibly mislead people. Does everybody have the long division in their notes? Can I erase it? I'm going to give you a synthetic division problem. And I want to see, this has a high risk of tripping people up. I want to see who can avoid the trip. Do it. You're welcome to do long division. You're welcome to do synthetic division. I'd actually like to do synthetic division this time. Can somebody tell me the box number? No. 3, correct. +3. Because you set the divisor equal to 0 and solve. What do I put here. This is the point where a lot of people can trip. Let's see who catches this. What do you put first? 1, I agree. What do you put next?
0.
Excellent. Why?
Because you need different places, but there's something.
You remember how I said you had to put all the missing terms in? Same thing with synthetic division, although it's a heck of a lot faster. This is the x to the 4th, this is the x to the 3rd. What's the next one? Keep going. Another 0 for x squared. Another 0 for x. Finally, you get to negative 16. Follow that? As long as you fill in the missing terms with zeros, it should still be good. Somebody run this for me? Let me see. Becca, help me out. What do you do first? Yeah, 1 plus nothing is what? 1. Multiply. 3. Keep going. Add is 3. Multiply. Add. Multiply. Add. Yeah, no. And then multiply? It's annoying. Sorry. I do 3 times 20 and then 3 times 7 and put them together. 81. Good. Add. It's another annoying. It is. Actually, wait a minute. 71. Yes. 65. Can somebody translate that bottom row and tell me the quotient? Those are the numbers we need. I just need to translate it into a polynomial form. Very clear. What did this used to be? There's 1x to the 4th. What is it now? Yes, keep going. Plus 3, what? It should just follow a pattern. 3x to the 2nd plus 9x plus 1. What is that thing? It's a remainder. 65 over what? Look at the original problem. You're done. That would have taken the better part of 6 or 7 minutes, long division. Even turbo speed would have taken about 4 minutes. Took less than 1 minute. Questions? Okay. I'm going to show you one more thing. But that was a review from yesterday. So that should hopefully catch up people from. Is there people else? Everybody got this on the right hand side? There was an implication. I told you something about synthetic substitution, which is actually kind of fun. F of x is equal to 3x to the 5th minus 6x squared plus 4x minus 10. And I would like f of negative 2. This is not a horrendously hard problem to do, but it's tedious. We discovered something, and hundreds of years ago, somebody discovered something. They had invented, whoever they were, invented synthetic division. And then a little while later, they discovered it has a very interesting benefit, completely by accident. Synthetic division is used to divide things, but just by accident, it also does something for free. Use this to plug in as the box number. Again, I would never have known this. Somebody was taking years out of their life as a mathematician, hundreds of years ago, and just stumbled upon this. Or just were so brilliant that they saw it or something. I'm going to set this up like synthetic division. This is x to the 5th. There's no x to the 4th, no x cubed. Here's the x squared, here's the x, and here's the constant term. Let me see what I just did. Does that make sense? Now, why am I dividing when it's not a division problem? Excellent question. Let me just run this. Add, multiply. Add, multiply. Add, multiply. Add, it's getting harder and harder. Multiply. Add, multiply. Negative 128. Negative 138. not gonna work it all out for you. Well, actually will, should I? Yeah, why not? F of negative 2 is 3 times negative 2 to the 5th power, plus negative 6 times negative 2 squared, plus 4 times negative 2, plus negative 10. I'll do the tedious work for you, because I want to show you something, and it's rather dramatic. Negative 2, you got to do exponents first. Negative 2 to the 5th power is negative 32. Just ignore that. And then negative 6 times, this is positive 4, because negative 2 squared is positive 4, plus negative 8, plus negative 10. This is negative 96. Negative 96 plus negative 24, plus negative 8, plus negative 10. Negative 96, negative 100, negative 120, negative 138. Interesting. Look. That's not a coincidence. If you run synthetic division, which is usually a lot easier and less tedious than plugging it in, especially if this thing were like to the 9th power or something like that, ouch. You know, I just happen to have memorized a bunch of powers of 2 in high school because I was totally without a life at that point, and I was really bored in geometry. But I digress. But anyway, my high school algebra teacher was a math god. The geometry teacher was a pretty good basketball coach. I'll leave it at that. Does everybody see what happened here? In other words, if you want to plug in a value, you can run synthetic division with the plug-in as the box number, and it will give you the plug-in value at the end. The remainder is the same as the plug-in value. In other words, this is something called the, please write this down, the remainder theorem. Remember theorems from geometry. I'm sorry if I cause post-traumatic stress flashbacks for that geometry. But a theorem is something which has been proven. Go. Yeah, proven. The remainder theorem is something that is true about these things, that has been proven. You don't have to prove it, just take it on faith. If you ever want to prove it, I'll help you prove it. But the remainder theorem says this. F of n, whoops, I'm sorry, hold on a second. It's not actually worth of anything. F of A, where A is any number you like. F of A is equal to the remainder of f of x divided by x minus a. This works both ways. If you want to get the plug-in value, find the remainder. Or if you're in the mood, if you want to get the remainder, find the plug-in value. Let me show you where that might come in handy. Do you see that this thing was, the remainder was 65? On this previous problem? Watch this. Let's just say f of x is equal to x to the 4th minus 16. That's the thing you're dividing in. Can somebody find f of 3? Anybody know 3 to the 4th power? 3 times 3 times 3 times 3. Yeah.
It's like 243.
One too many. That's 3 to the 5th. 81. So it's 81 minus 16. Okay, mental math people. What is that? That's the remainder. If the book says, give me nothing but the remainder, you have a quick way of finding it by just plugging in. Now, we got lucky. When would I use the remainder theorem? When you have really nice short polynomials. Let me show you one where the remainder theorem is a gift from God. Does everybody can this? This f of negative 2 thing? Okay. Watch this. Find the remainder x to the 20th minus 3 over x minus 1. All I want you to find is the remainder. You might be asking in the back of your mind, when would anybody ever want the remainder and nothing else? I'll answer that tomorrow. For now, there is actually a very, very good reason why you might. I'll tell you tomorrow. For now, how do you do it? By the way, there are 3 methods. One is long division. You first. Not doing it. Not it. Basically, x minus 1, I'll show you what it would look like. X minus 1 into, and you remember what we have to do with missing terms? X to the 20th plus 0x to the 19th plus 0x to the 18th plus blah 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 plus 0x squared plus 0x plus negative 3. And you don't do the dot dot dot. That doesn't work well. You'd have to write the whole thing out and then grind. This thing would probably take at least 15 minutes, and that's if you stay focused.
Like 4 pages.
It's tedious. Aha! Synthetic division is so much faster. Well, it is. I agree. 1, the 19th power, 18th, 17th, 16th, 15th, 14th, 13th, 12th, 11th, 10th, 9th, 8th, 6, 5, 4, 3, 2, 1, and then negative 3 down here. So you're going to have to add and multiply 21 times. Again, a heck of a lot faster than long division. I hope you agree. But, watch this. Can somebody do, what's the box number? In this case, Kitty. What's the box number if you're dividing by x minus 1? 1. Plug that in. Can you do 1 to the 20th power minus 3? Anybody? What's 1 to the 20th power? 1. What's 1 minus 3? You just found your remainder. The remainder theorem says plugging in will give you the remainder, and the remainder will give you the plug-in. It works both ways. Yeah, perfect. Questions so far? Does that make sense? I know after a brain frying test or whatever, or did you have a test today? Okay. Oh, a couple so of you did. Okay, I realize it's not the most exciting thing in the world to plunge into the remainder theorem after you just had your brain fried with CLT. That being said, it will come in handy. Open your books, please.
You just did this.
Open your books, please. Gentlemen, that would require books. Yes. Look over, yeah. Now, you will, but let me go through this first. We are looking at page 61. Page 61. It's, the reading starts on page 58. This is for homework 2B. In the paper. Prepare not to be. So, go ahead.
You're not going to do 2A?
Yeah, we talked about that earlier. I'm going to be checking that off tomorrow, just to give us some time to work in class today. We're going to check off 2A tomorrow, and then 2B. By the end of the hour, I'll tell you whether 2B is due tomorrow or not. I honestly don't know. The earliest it'll be due is tomorrow.
Okay.
It might be due Thursday. Wait a minute. What is today?
Yeah, tomorrow.
Today is Wednesday,
Yeah,
right?
tomorrow's Thursday.
Then it would be, yeah.
Right, it's Friday. Yeah,
It would be due the day after tomorrow, whatever that is. Okay. By the way, I get that. With the garbage. Watch this. We're looking at page 61. I want to look at problem number 13. It says, which of the following are factors of that polynomial? X cubed plus negative 5x squared plus 3x plus 9. What is a factor? Now, we went through a chapter on factoring last year. And if you were with me in 8th grade, we went through it then as well. There's 7 basic methods of factoring. We reviewed it in here too. GCF, unfoil, binomial squared, difference of 2 squares, grouping, magic pair, substitution. So people know how to factor, but sometimes, gentlemen, get you focused up here. They might not know, gentlemen, you too, what a factor is. Write this down, please. X minus A is a factor of f of x if the remainder of f of x divided by x minus a is 0. How do you know if something's a factor if it divides evenly? Like 3 is a factor of 12, because if you divide 3 into 12, you have a remainder of 0. There's no remainder. It goes in perfectly. Same thing with polynomials. Every once in a while, we had a remainder of 0, which is like win the lottery level lucky. But that means you found a factor. Let me just demo this real fast. Example. X minus 3 dividing into x squared, let me see, yeah, minus 10x plus 21. What the heck? Brain? And get together. 21. I'm going to add the opposite. Can somebody just talk me through this? It's relatively short. Do long division, just for old time's sake. Let me see. Mary, help me out. What do you do first? I'll allow you to do synthetic division if you want. Do you have a preference? What's that? Synthetic, okay. What's the box number?
3.
3. Give me the numbers over here.
1, 10,
Negative 10.
21.
Good. What's the technique? Run me through it. What do you do first?
Add 1.
Add.
0, 6,
1. And then
1. Multiply times 3.
multiply. Correct. Then add.
And then negative 7.
Multiply.
Negative 21.
Add.
0.
This is the remainder. Can you translate that bottom for me? This used to be 1x squared. What is it now? 1x plus negative 7, and then that's it. Does everybody remember this so far? If you have a remainder of 0, then x minus 3 must be a what? By this definition. If you have a remainder of 0, you just found a what? Go. A factor. You found something that goes in evenly. And let me show you something. This is something from 8th grade, actually. X squared minus 10x plus 21. So I divided x minus 3 in, and I basically got x minus 7 up here. Can somebody factor this thing for me? It unfoils, actually. What two numbers add up to negative 10 and multiply through 21?
Negative 7, negative 3.
Negative 7, negative 3. Really? In other words, when we were factoring, what we were secretly doing is kind of doing long division in our head. It's a very, very short way to do long division. If you can factor something, it's usually far easier and far faster than taking long division, especially if you have like a 7 or 8 term polynomial. If you can factor by grouping or factor by GCF or whatever, it's usually much, much easier than dividing it by hand. How do you know if you have a factor? If the remainder is 0. And here it proves it. When we did factoring, we're breaking it into 2 pieces, both of which would have a remainder of 0 if you divided it. If I divided this thing by x minus 7, guess what I would get? I divided it by x minus 3 and I get x minus 7. Anyone want to take a guess at what would happen if I divided by x minus 7? Okay. The remainder is 0. What would I get as a quotient? The other factors. If you divide the big thing by the first factor, you get the second factor. If you divide this big thing by the second factor, you get the first factor. Does that make sense? Now let's go to the book. Now you'll know what they're asking. Number 13. Which of the following are factors of that? They gave you 4 terms. This is tantalizing. X to the third plus negative 5x squared plus 3x plus 9. There are 4 terms. Guess what you'd probably try and do if you're looking for factors? What method might work here? Yeah, factor by grouping. Did anybody try it? There is a way to tell ahead of time if factor by grouping is going to work. This is actually what I do on answer keys. Everybody look up here for a second. X cubed plus 8x squared plus 3x plus 24. I guarantee you that does factor by grouping. How do I know? And because I designed it, but yeah, right. There's a reason that works. Look at the numbers in front. Compare them. See a pattern. 1 goes to 8 as 3 goes to 24. These are called proportional. If the first and last pair of terms are proportional, it will factor by grouping. Look at this one, number 13. X cubed minus 5x squared plus 3x plus 9. Does that look proportional? No. That does not factor by grouping. In times past, in the good old days, you tried factor by grouping. It's a 4-term polynomial, and if it didn't work, you wrote prime. In this case, that's actually not true. This thing factors, but not by any method we've ever learned before. Tomorrow, we're going to be learning a brand spanking new way of factoring. Don't take that away. So can somebody tell me, how do you test whether x minus 1, in other words, I hate to put it this way, because I've always mocked this, the phrase guess and check. It's not even normally worthy of the dignity of being called a method. It's like, did I hit anything? It's got to be a little more intelligent than that, but it is guess and check. What I want to do is on number 13, they want to see, is x minus 1 a factor? There's only one way to find out. Try it. X to the third minus 5x squared plus 3x plus 9. The longest way to try this is do long division. See if the remainder is 0. If it is, then congratulations, you got a factor. Is everybody with me so far? Don't unfocus. That's fatal in these things. This is going to get more and more complex. You will not feel it being more and more complex unless you unplug from the lesson, in which case you will have a whole lot of hurt in a very short period of time. Trust me, pre-calc is called pre-calc for a reason. It's not arithmetic. It's complicated math. If you stay with it every day, piece by piece by piece, it'll feel easy. If you unplug and then try and catch up 7 days later, God help you. Seriously. There are people who can do it, but usually the people who are that brilliant and can do it are usually diligent enough to stay with it anyway. So, friendly warning, don't unplug. Don't get distracted. How do you tell if this thing is going to be, if x minus 1 is a factor? Weld into your head this new idea. Something is a factor if the division has a remainder of 0. That means if it goes in evenly. There's only one way to find out. Try it. You can do long division, see if the remainder is 0. You can also do synthetic division, see if the remainder is 0, which is a lot faster. Can anybody think of an even faster way? All I want is the remainder. I don't really care about the rest of the quotient. I just want the remainder. Is there a way to get the remainder and nothing but the remainder? The remainder, the whole remainder, and nothing but the remainder. so help me God. Plug in the box number. Plugging in the box number will give you the remainder. It's called the remainder theorem. The remainder theorem says if you plug in the box number, you will get the remainder if you divide it by that. Let's find out. 1 cubed minus 5 times 1 squared plus 3 times 1 plus 9. This will give us the remainder. What are we hoping and praying that the remainder is? What? 0. We're hoping it's 0. Let's find out. What's 1 cubed? Anyway. Don't worry too hard. 1 minus anyway, 5 plus 3 plus 9. Add them up. 1 minus 5 is? One minus 5 is? Theo, Will, save us. 1 minus 5 is?
-4.
Plus 3?
-1.
-1 plus 9? 8. That's not 0. Is x minus 1 a factor of this thing? No. End of problem. I mean, that's part A. They give you 3 different ones, part A, part B, and part C. Part B says, is x plus 3 a factor? You try it. And then they ask, is x minus 3 a factor? Plug in the box number and test it. See if you get an answer of 0, which is the remainder. Questions? So we have a very quick way to find not only remainders, but if something's a factor or not. The whole reason I gave you a quick way to find the remainder by plugging in the box number is because we need to find the remainder quickly. If they say, here are 4 possibilities, which of these are factors? If we're just guessing and checking, I want a nice quick way to test. I don't want the way to test to take 15 minutes each crack. Can you imagine if you had to long divide all of these? It would take forever. One last question. Then we have a little time to work in groups, and you'll have a lot of time to work. I'm putting off the homework till Friday, by the way. So the homework that was going to be due today is due tomorrow. This new homework is going to be due on Friday. Yeah, I'm not going to force you like that. But tune in for this. Front row. Hopeless family. Does x to the 5th minus 32 factor? Does it factor by difference of 2 squares? In your opinion? No. What's wrong? There's 2 things wrong with that. It has the right number of terms, and I like the minus.
32 is no square.
Yeah, 32 is not a perfect square. 36 I would have liked. 32, no. How about x to the 5th? Is that good or bad? It's bad. X to the 4th would have been decent, because it splits into x squared. Anything with an even power, I'd be willing to try. Anything with a perfect square, I'd be willing to try. This thing is a disaster. We have no other methods. Unfoil only works with a degree of 2. Magic pair only works with a degree of 2. Factor by grouping needs 4 terms. Binomial squared needs 3 terms. No GCF. Substitution doesn't work. We're done. Guess a box number. I want you to just try a few numbers and see if any of them work. And I'd like you to start small. I want to know if x minus 0 is a factor of this thing. There's a way to find out. It's not a sneaky way, but let's do it the official way. the box number would be 0. You could do synthetic division, but there's a much faster way to do it. Sam, how would you do it? Okay. Did you get the question? Okay. We're trying to find out, we're just going to start guessing some factors. Like I'll try x minus 0, x minus 1, x minus 2. Does everybody say that this is going to be a very inefficient way to try and find factors? Because there are an infinite number of these things. I mean, we could stop at 32, I suppose, because they won't be any bigger than that. But I need a way to test if these are actually going to work or not. Austin, help me out. How would you test x, box number of 0?
Just like put 0 in.
Put 0 in place of x. In other words, what's 0 to the 5th minus 32? Negative 32. Is that a factor? No. Why not? Why did it fail? Yeah, I did not get an answer of 0. An answer of 0 for these things is striking gold. It's a, making it rich. I hate to use wealth metaphors. Makes me think that getting rich is the best thing that ever happened to you. Try a box number of 1. Courtney, try it. Exactly. Plug in 1 for x. What's 1 to the 5th? 1 minus 32? Negative something. Negative 31. Good or bad? Bad. What were you hoping the answer would be? 0. Becca, take over. Try box number of 2. 2 to the 5th minus 32. Now 2 to the 5th takes a little bit of work. So start to me again. What's 2 times 2? Times 2? Times 2? 16. So it's 2, 4, 8, and then the next one is, and then just double it again. 32. So is that the last one or the 2, 4, 8, 16? That's okay. You actually got it. It's 32. This is 32 minus 32. What's the answer? Is that good or bad? That is good. X minus 2 is a factor of this thing. I don't know how to do it. Actually, I do, but I'm pretending I don't. I know that if you factor this thing, you will have x minus 2 times something. I don't know what the something is. No clue. We can find out later. But do you see how that works? We found that by almost random chance. You plug in a number and said, glory be to God, the answer is 0. The remainder theorem says that the remainder is 0. You just found a factor. It divides it evenly. Why do we care? Because eventually, just as a teaser, I was telling you about advanced ways of factoring. By the end of next week, I will be able to put a polynomial here of degree 8 with 9 terms, and you will be able to factor it completely. Okay. There are a couple of techniques we need to learn first. This is one of them. All you need to know for now is if you're guessing at random, if you say, I wonder if x minus 2 is a factor, or x plus 3 is a factor. By the way, if you did x plus 3, what would be the box number? Yeah, negative 3. And just try all of them. It's not feasible to do this for every single number on Earth. Eventually, I'm going to teach you how to whittle down the list of numbers. We will eventually be able to whittle it down to like 12 possible numbers or something like that. It's not instantaneous. But again, probably by the end of next week, and certainly by the end of the following week, everybody in here, if you plugged in and if you master the technique, should be able to factor enormous polynomials. Okay. For now, that's about all we have. So I'm planning to, I think I've given you all the notes you need for 2B. I think I'm just gonna make tomorrow a clean work day. And then I'll take the last 10 minutes-ish on the end of tomorrow, check it off. Or if everybody's done halfway through, great. But otherwise, I'll give you plenty of time tomorrow. We'll check off 2A, go through any questions, send you on your way, and then Friday we'll check off 2B. Deal? All right, people listening at home, this is my hand waving goodbye. Talk to you later. Am I hitting the right button here? Up or down?